How much in my class? About 12? All right. So, mouse. All right. Good morning, everyone. Just checking that you're seeing the screen and that you're also hearing me. Yes, no?
Yes, sir. Hearing you, seeing the screen.
All right. Thank you, Simone. Thank you. All right. So today, we're going to continue this journey into reliability. I know last week you approached the subject of reliability, and you also looked at one measure of reliability, which was the last class, the kappa statistic. Today, we are going to look at another measure of reliability, the so-called Cronbach's alpha. I'm sure last week you would have been mentioning a number of different kinds of reliability: inter-rater reliability, intra-rater reliability, split half reliability. And something that would have been mentioned to you would have been internal consistency reliability. And Cronbach's alpha is a measure of internal consistency reliability. And that's where we're going to focus today. So, very commonly, we encounter in the real world and in statistics instruments that are often constituted of a number of items that seek to measure the same variable, seek to measure the same construct. If this is so, it is useful to ensure that they are, in fact, measuring the same construct. And therefore, to assess that, we often do some examination of reliability. And in such cases, reliability can be seen as the degree to which different items are consistent with each other. Now, many of you may recall, doing lots of quizzes and so on. And there was a time I remember before computers were around, when you traveled on aircraft, they would give you these magazines. And the magazines would have a little thing for you to just pass time when you were, traveling. And they would ask things like, how good a listener are you? And they would, have a series of questions. And they'd ask things like, I am very attentive to other persons when they speak. And they would give you, agree, strongly agree, and so on and so on. And they put another item. I rarely give a listening ear to people when they complain. And you put another thing. And another one might say, to be honest, I don't entertain others regardless of what they have to say. And you agree, disagree, and so on. And at the end, having completed, they would give you a key at the bottom to say, score 5 if your answer to question 1 was that. 4 if it was disagree. 3 it was so on. And at the end, having scored all the items, all the questions, you'd come up with a score, overall score. And then they would say, if you scored between 1 and 20, you're a poor listener and you need to go to some classes to improve your listening skills. 20 to, 54, reasonably good. 54 to 89, very good listener. 90 to 100, you're the greatest empathetic and listening person in the world. Those are all items trying to measure your willingness and capacity to listen to others. So that's the construct. And you're assessing that construct using various items. So to the business of, are these items internally consistent with each other? We're going to talk about what exactly do we mean by internal consistency. Very often, we assess internal consistency reliability by giving a single measurement instrument to a group of people, and then we do some calculations to estimate reliability. We look at to what extent do the different items that construct or constitute the instrument give similar results. In other words, we are looking how consistent the results are for the different items that are measuring the thing, the construct that we are interested in. In other words, we are looking at how internally these items are consistent with each other, and therefore we assess internal consistency reliability. Think about a questionnaire. And the questionnaire is to assess your likability or your affinity for maths. And let's say you have a question that says, I love numbers. Strongly agree, disagree, so on and so on. And you have another one that says, I score very well on maths test. And you have another one that says, I do not like logical thinking and logical arguments. I am more a touchy-feely person. What you would expect is that the person who says, I love numbers, and they say strongly agree or, extremely, and would also be the person who says, I do very well on maths tests. They would all, and strongly agree, they would also be the person who says, I strongly disagree with the idea that I hate logic and I'm just a touchy-feely random person. The mathematician generally, we would expect to say, no, I disagree, because we know that people who like maths tend to like structure and order. And so we can see if the persons who say, I love maths and score well on maths tests, would they say, I disagree with the idea that I hate logic and order? Now, they show them. And if they would, they did, then those items would be giving the same idea over and over, reflecting it in the same way, giving similar results, and therefore would be internally consistent with each other. Now, how do we measure internal consistency, reliability? There are a number of ways. One way is to look at the average inter-item correlation. So we get the instrument and we identify the items that are there to measure some construct, the same construct. We look at the correlation between each pair of items. And then we take the average of all the pairs of correlations. And then we will have the average inter-item correlation. So let me create a little questionnaire here. And pens here, pen. Let's go color red. And thickness, let's reduce the thickness a little bit. All right. So let's say we are trying to measure some kind of construct like how bourgeoisie you are. And I have an item here. I am going to create some questions. I enjoy shopping in Paris every summer. And you have some items: strongly disagree, agree, undecided, strongly disagree, or the reverse order. So let's say we have this: strongly disagree, disagree, undecided, agree, strongly agree. So that's item one. You have another item that says, I am always attending high fashion shows. And we have the same thing: strongly disagree, disagree, undecided, agree, strongly agree. And then I make up another one. I mostly eat salmon and caviar. Smoked salmon and caviar. And another one that says, every day I have a glass of vintage Beaujolais Village wine. And again, we have the same things. What we look at is, what is your answer to this? Let's say that you have strongly agree. And for the next one here, you have agree. And the next one here, same idea. And let's say you put strongly agree. And then for this one, the person says strongly disagree. Normally, we have some kind of system that scores these items on a Likert scale. And we would we have something that says this is a 1. I mean, the more bourgeois, the higher your score. The more upper crust you are. And similarly here, the scores might be 1, 2, 3, 4, 5. And here, 1, 2, 3, 4, 5. We can assess the correlation between the answers on this question and the answers on, let's say, question 2. So imagine that we had many participants. Many participants. Question 1. Let's graph these participants. We get the first person's participant. They said question item 1 and item 2. So questionnaire number 1, the person answered 5. So let's see if we can score this with 5. And on item 2, they answered 4. So it's item 1, score 5, and 4. We kind of just concentrate on the first 2 items, item 1 and 2. Let's take another questionnaire. Somebody else. That person answered a 5, but on question 2 answered 3. So I go 5, 3. Let's take another person. They answered question 1 with a score of 1, strongly disagree and strongly disagreed. So their score was 1, 1. Another person, for those 2 questions, answered 4 for question 1, 3 for question 2. So they would have been a 4, 3. Another person answered 2 for question 1 and 2 for question 2 for item 2. And another person answered 5 for question 1, but 1 for question 2. So 5 and a 1. Another person answered 5 and 5. Another person answered 4 and 3. And we could plot the scatter diagram looking at the scores obtained in your sample of persons for these 2 questions. And you might see a trend. And the trend might indicate a pattern which you could assess via correlation. So you can get the correlation between item 1 and item 2. Let's say you did that and you got the correlation to be 0.89. Item 1 and 2, correlation 0.89. We could do the same thing, item 1 and 3 for all the questionnaires. And we could map it again and see the correlation between item 1 and item 3. We could map correlation between item 1 and 4. And then when we get the correlation coefficient, you can get that. And between item 1 and 5. And between item 1 and 6. This being a 6-item questionnaire. But that's not where it ends. What about the correlation between item 2 and item 3? Or item 2 and item 4? Item 2 and 5, item 2 and 6? We could assess all the possible pairs of items and get correlations. Nice and tedious if you're working by hand. Thank God they have computers that can help us do that. But if you were to take all these correlations, and there are 15 of them, 5 and 4, 9 and 3, 12, 12 and 2, 14 and 1, 15, we could then add up all these correlations and divide by 15. And that would give us the average inter-item correlation. And if you probably do this, you'll probably get something like 0.9. And that will be interpreted as a fairly high correlation. And therefore, the items are well correlated with each other. They are internally consistent with each other. They are saying the same thing, generally speaking. If you score a 5 on question 1, you're probably going to score a 5 or a 4 on question 2, item 2, and so on. And therefore, we get an idea of how well the items tend to reflect the same construct by looking at the average inter-item correlation. Now, this part of it here is just, you could have sat down and actually just write out all the possible pairs. If you don't like it, you can go to permutations and combinations to find how many different ways are there of combining 6 items 2 at a time. That's your pairs. And you can use your factorial formula and you'd find that there are 15 ways of combining 6 items 2 at a time. And all the 15 ways are actually listed there. That's a sideshow. So one way is to look at the average inter-item correlation. Tells us how well these items fit together in trying to measure that same construct. Another way to look at how well these items fit together. How well are they correlated? How well are they consistent with each other, giving the same answers? We can look at something called the average item to total correlation. Item to total correlation. So what we would do now is using the same idea. Just go back here. We would take the score of person 1. We look at what they score on item 1. Let's say they score 5. And then we look at what they score on all the items and total it. So this person would be a 5 plus a 4, that's a 9, plus a 5, a 14, plus a 1, a 15. So this person would have 5 on item 1 and a 15 in total. Another person, when we look at their answers, they might score, let's use a different pen just to reflect another person. They might score 4 here. No, they might score 1 here. These are their answers. They scored 2 here. They scored 3 here, and they score 1 here. That person would have scored 1. And would have scored overall 1 plus 2, 3, and 3, 6, and 1, 7. 1, 7. And let's also take a third person, just to illustrate the point. We represent that person as green. They score a 4. They score a 5. They score a 4, and they score a 4 here. So they would have scored a 4 on item 1, and then total 4 and 5, 9, 9 and 1, 10, 10 and 4, 14. And so we could actually compute that for all the persons in our sample and draw a diagram for item 1 versus total. Item 1 versus total. So we'd map it. 5, let's say these are 5s, 10s, 15s, and these are 1, 2, 3, 4, 5. This person, 5, scored a 15. So it would be there. Number 1, item at 1, scored a 7, somewhere here. Now, who person scored 4 here and scored 14? Which is somewhere there. And we could map all of this and see the item to total correlation. We do it for item 1 to total, item 2 to total, item 3 to total, item 4 to total. So you might, if you had the raw data, here's what you get. Item 1 correlated to total, 0.84. Item 2 correlated to total, 0.88. Item 3, 0.86. Item 4 correlated to total, 0.87. Item 5 correlated to total, 0.83. And item 6 correlated to total. And then we take the average of the item to total correlations. So these numbers, add them up, and we divide by 6 and get the item total correlation. So it kind of tells us how each item fits with the overall picture. That's another way to look at the linkage, the relationship, the idea of them being consistent with each other. Sometimes people decide to do something called the corrected item total correlation. Corrected. Now, what the corrected means is that in computing the total, you don't include that item. So here we looked at items 1 score compared to all the other items were included in completing the total score. The corrected means that you take item 1 score and the total, corrected total, is the remainder. So you don't include item 1. In other words, what you're really looking at is how item 1 compares with the rest of the items. Item 1 not included. So you'll be looking at item compared to corrected total. So the correct that item score in computing the total. So that's another option that is available. Some people prefer that because they say when you include the item in the total score, you know, the correlation is going to be enhanced because that item will be correlating with its score itself a bit. So if you really want to see the picture, the corrected item to total correlation is better. That's another way to do it. And then there is the most popular way for looking at the relationship, the reliability for items within a scale. And this is Cronbach's alpha. It's perhaps the most commonly used measure of internal consistency or reliability. This measure shows the consistency of a multi-item scale. Normally, we use Cronbach's alpha when we have several Likert type items, which are grouped together to make some composite scale and generate some kind of total or composite score, and then we make some judgment. Do you know of any instruments that are constructed in this way that you've met during your sojourn? The MBTI, yes, it is. It is. And if you read the front of the MBTI, you should see actually there, at the front or the notes at the back, they should tell you the internal consistency of the instrument so that you know that you are using a pretty reliable instrument. Anything else that you've come across where you have several items and at the end you come up with a score, you sum up, you come up with a score, and it's supposed to reflect something.
Survey.
What kind of survey?
A survey that has like score. So do you strongly agree that the service was good, etc.?
And then you come up. So she's saying, class, that sometimes you have a survey to rate the service. And there are several items that say, it might say, you know, how do you rate our punctuality? How do you rate our friendliness of staff? Did you find the bathrooms clean? And so on. And then you tick them off and you get a global score.
It could also be like, I don't know, like a lot of BuzzFeed surveys where it is like you pick different items and then they say, guess what kind of, I don't know, item or what your personality.
Exactly. These things, in psychiatry and psychology, we have a lot of these scales. In fact, the mini mental status exam asks you to do some things and you get some scores, and at the end of it, you get that. Many of the depression instruments, the Zong depression scale, Beck depression, the center, the PHQ, gives you these items and you sum up and you get a scale, and they at the end they say you're mad or you're not mad, or you're depressed or you're not depressed, and so on and so forth. So these are very, very common. In fact, one of the things that used to be in the Air Jamaica, when Air Jamaica had planes, in the magazine, was a little question. Are you a good lover? And they ask you some series of questions and so on. And at the end, you sum up. This was supposed to be fun when you're traveling on the airplane. You sum it up and then you say 0 to 20, why you need to go to love school. 20 to 21, you should be teaching in the love school, and so forth. And so that's always there. But there are many, many, many instruments that are based on this. Now, a couple of things to note about such instruments. There's assumption that we are trying to measure the same concept. So all the items are trying to pick up depression, or the items are trying to pick up your brain functioning in the mini-mental state, cognitive function, etc. Or the IQ, the question to test your intelligence quotient. They give you a series of questions and you get a score. And they say your IQ is 141 or your IQ is 39. I know nobody in this class has an IQ of 39, and so on and so forth. All right, so the assumption is that we are trying to measure the same construct, and the items actually measure the same construct. The second is that the items are systematically related to each other in a linear manner because we think they are measuring the same thing. And you remember we were looking at correlations and we were assuming linear correlation. So that's why we could calculate a correlation coefficient. So therefore, these measures are similar or comparable. Therefore, if you find differences in the items, it must be due to measurement error. Because if you like shopping in Paris and you say strongly agree, you should also say, I am very high fashion and I eat caviar every day. And, I only travel first class, because we are trying to capture the concept of you being a member of the bourgeoisie, right? Bougie, as them say, you're too bougie, or the bourgeois. So we're trying to capture that. And they should be measuring the same construct. Therefore, if you are not essentially ticking off things in the same way, it means that something is wrong. Either that the questions are not measuring the same thing, or sometimes you have random fluctuations in scores or error. Now, measurement error, I'm going to jump the gun a little bit. Measurement error occurs from two sources. You know this because you've done all your epidemiology. It could be random error or systematic error. That's inducing bias. So when we assess it, it could be that just some random fluctuations on the scores could happen. Or maybe the items really don't fit together and there's a systematic problem in how you're trying to measure this construct. If they fit together, then we should have high correlations and most of the error should be due to random error rather than systematic errors. Cronbach alpha, continuing. You have already seen that one way of trying to assess reliability of an instrument was to take the instrument, I think it would have been mentioned in your class, and divide the instrument randomly into two. And if that is the case, and the instrument is measuring the same thing, then one half of the questions should be highly correlated with the scores on the other half. Make sense? So, we can assess split half reliability, because this is what we do. Cronbach's alpha actually is a special case of split half reliability. So, an example of split half reliability. Let's say that we have a 6-item question here. We could randomly split the item, the instrument into item 1, item 3, item 4. And then the other half will have item 2, item 5, and item 6. That's one possible. And then we look at the correlation of the scores on those 3 items and the scores on the other half, the other 3 items. Let's say it works out to be 0.7, 0.87. Then the split half reliability for this particular separation is 0.87. Make sense? We'd have to look at the scores, the raw data, and come up with that. But guess what? This was only one possible split half. Instead of item 1, 3, and 4, suppose we had split in half item 1, 2, 3, and the other half item 4, 5, 6. We could do this and check out the correlation. We could also randomly assign the numbers again. Item 1, 2, and 4, and look at how those relate to 3, 5, and 6. We could do item 4, 2, and 3, and see how that works with item 1, 5, and 6. So notice what we are doing. We are just splitting things in half. All different combinations of split halves. When we do it for the first one, we might get 0.87, for example. We do it for the second one, we might get 0.85. We do it for the third one, we might get 0.91. And we could continue doing more of these. All possible split half combinations. After a while, we'd have exhausted all the combinations. And if we take the average of all the split halves, we will end up with Cronbach's alpha. So Cronbach's alpha is really the average of all the possible split half correlations. Now imagine that if you had to actually sit down and do this for 6 items, it will take a little time. By the way, this is N, right up to N, whatever the N combination is. Can you imagine if you have an item that is a 20-question instrument and you're looking at all the possible combinations of 10 versus the other possible combinations of 10? Or if you have 100 questions, it would be tedious. Thank God, computer programs exist to do this. Just to keep splitting it in half and come up with the combinations, plus all the possible combinations, and then average them. And that gives us Cronbach's alpha. Now, we could ask you to do this, but we will not, because SPSS exists to help us. And this Cronbach's alpha is really very good, because what you're doing is taking all the correlations of the split halves and then seeing on average, what is this? It's almost like the average inter-item and the average other one, but this one has the element of randomness to it, and certainly is recognized and is quite useful.
target, like you mentioned before with the MBTI, where it is that there's supposed to be, I guess, a threshold that it is that it's reliable.
So the question in class is, when you come up, suppose you came up with 0.45 instead of 0.85, is that a good answer? Or suppose you came up with 0.3, is that a good answer? Or if you came up with alpha 0.9, is that a good answer? I'm going to hold the answer to that for just a while. Because at some point, you'll have to decide on what is an acceptable Cronach's alpha. The assumptions we mentioned already, so I'm going to probably skip all of these things. And the reminder that measurement error consists of random error and systematic error. So we're going to actually do this using an SPSS database. You have a database called MPH Cronbach's, and we are going to use that database to illustrate the assessment of reliability of items that constitute a particular instrument. So make sure you have your Cronbach's MPH database handy. And I'm going to show you the questionnaire that was used to fill this database. It's at the end of your notes. So here is the questionnaire. The ATCOS survey instrument. And the ATCOS survey is about examining attitudes to condom use. This instrument is a 6-item instrument and has the following items. 6 or 5, 6, I think, yeah, 6. People should be free to use condoms. And there's a Likert scale: strongly disagree, disagree, undecided, agree, strongly agree. Condoms are bad for health. And there you have your responses. Condoms save lives. Response. Next items. Condoms are useless. Next item. Condoms are great for sex. And then the next one, I would recommend condoms to my friends. This is supposed to assess your attitudes towards condom use. The ATCOS instrument. Has anybody ever used this instrument? The ATCOS? You should not have used it because I made up this instrument. But you know, when you go abroad and you talk about the ATCOS scale, you know, they actually believe and think you're a real expert and the scale look good, you know. It looked like it could actually be used to measure attitudes, but it's not a real scale. But I'm gonna develop it further and, you know, pilot it. All right, so a couple of things, I'm gonna come back to this page on page 12, but a couple of things to note just in the notes. So the database that we are going to develop will see the responses to that questionnaire. This questionnaire, as we mentioned, sought to elicit attitudes towards condom use. Responses were coded 1 to 5, such that the most desirable responses were given the highest score. The most desirable responses from a public health perspective were given the highest score. So if we go to our instrument, right now, as they were originally coded, I'm going to write on the original codings. So these were 1, 2, 3, 4, 5. And when they were setting up the question, they just said strongly disagree equal 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then just go a little further down. You know, when you're designing a questionnaire and you have a box, and you just sometimes people just put the 1, 2, 3, 4, 5 at the top, and then they have a little grid. 1, 2, 3, 4, 5, and they have the items, and people just tick in the box. The response to each item. 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that's how the database was originally set up. And on the questionnaire, that's how you normally would do it. Now you notice that some questions are positive and some are negative, right? Because they tell you in research methods, you must just ask all positive or all negative. Or what people do is they don't read the question, they just go down and tick. So let us look at the items and see if the most desirable response from a public health perspective has the highest scores. People should be free to use condoms. Is that set up such that the most desirable has the highest score? So that's okay. So the 1, 2, 3, 4, 5 looks good. Condoms are bad for health. What is the most desirable score? Or a response rather? The most desirable response from a public health perspective would be 1. So this one needs to get the highest score. And if you agree with it, you are basically going against public health principles, and that should have the lowest score. Because at the end, suppose somebody says, I strongly agree, and then condoms are bad for health. They strongly disagree. That person is going to get high scores on the instrument, which will be a favorable attitude. Condoms save lives. That is okay. So this one we had to reverse. Condoms are useless. Is that one okay? The most desirable response from a public health perspective would be this. Strongly disagreeing. So this one, we do need to reverse code. Otherwise, we won't be consistent with each other. The so-called negative questions and the positive answers. Condoms are great for sex. This one could be argued, but let's assume that this one is okay. We want people to at least believe that so that they can prevent pregnancies and STDs and the likes. And condoms, I would recommend to my friends, certainly the most desirable response from a public health perspective would be what it currently exists. So when we are setting up the database, in order to be consistent, we have to say the most desirable answer gets the highest score. Or you could have said the most desirable gets the lowest score too, but you just do it across all the items. Just like, which was it? It was A levers or CAPE and CSEC. The most desirable scores are the 1s, 2s, and then the 3s, 4s, and so come later. So they have set up in their system, the most desirable scores are the 1s and 2s. And so when you apply to the university, lower scores are the greatest scores. So it just depends on what you define as what is the most desirable thing. But be consistent. All right. So let's go to the database. Okay. Right. So people wanted to use the scale, and they said, before we use the scale, we need to check that the scale is reliable. You remember from your first semester, you want your questionnaires, your scales, your instruments to be valid and reliable. Validity is about reflecting truth, accuracy, precision. Reliability is about consistency, repeatability. So I'm just going to run through the process and then I'm going to go to the database. So we will go, as SPSS, as your notes say, to analyze, scale, reliability analysis. We'll give the name. We'll select what we call alpha here because we want to generate Cronbach alpha. We'll give the scale a name or a label. We will put across the relevant variables that constitute the scale, and then we will go up to statistics, and we'll tick off some things. Items, scale if item deleted, correlations, means, correlations, and click OK, and we'll get our output. So let's go to the Cronbach, the MPH Cronbach database. So let's start. Whenever you go to a database and nobody's told you anything, a good place to start is, okay, she gave you the reverse ones. All right. No, this one is not reverse, which is great. Which is the variable view. So the first part in the variable view has the 6 items in the scale. Condoms free to use, condoms bad for health. And I can pull this out if you want to see it. Variable name, short name. Condoms save lives, condoms useless, condoms great for sex, condoms recommend. Don't worry about the other 4 items right now. So here we have our 6 items. Let us look at the values and how they are coded. Here it is. The first one, condoms free to use. 1, strongly disagree. 2, disagree. 3, undecided. 4, agree, as it was set up originally on the paper. Then we see condoms bad for health. If you click on it, you look at the coding, you see 1 is strongly disagree, disagree, undecided, agree, strongly agree. So we will need for this item, for the best score, for the best answer to have the highest score, we will need to reverse code. So we need to say strongly disagree, we'll have the highest score, 5. Strongly disagree equal 5. Strong disagree equal 4. Strongly agree with that statement would get the lowest mark of a 1. So that item needs to be reverse coded. The next one, if you take a look, all right, close this. Oh God, I didn't close, my fault. Come on, pull it apart. The next one is condoms are save lives. Strongly disagree. Is there. And that one still has the correct coding. All right, because the highest one, strongly agree, would be the highest score, saying yes, it saved lives, get a 5. If you want to look, you can just glance at it. Strongly agree gets a 5. The next one is condoms are useless. Right now, strongly disagree is the best answer and ought to get 5. But right now, it's at 1. So that one needs to be reverse code. And the other two, like we did on the questionnaire, are okay. So before we get any further, we must reverse code bad for health and useless. So how do we do that, Lord? Well, you remember transform? So what we are going to do is reverse code. Set up a little system so that you know what's what. So these ones, they strongly disagree, should get 5s. So I'm going to go transform. Recode into a different variable. Remember, you want to keep your original data unless you never ever want to see it again. So you go recode into different variable. What are we recoding? Condoms bad for health. I could have done this simultaneously, the other one, but I'm going to do them one at a time. And it says condoms bad for health into what? So we're going to give a name for this new variable. I'm gonna call it CDN. You can use underscore if you want. But remember, no spaces in the variable name. Condoms bad for health. And then what I'm going to do, you could call it anything that you want. REV. Doesn't have to be capitalized. I am just doing that. Got the band for health. I think in your notes I might have used common letters. So let's call condoms bad for health. Capital or common, it doesn't matter, you do it. As long as you are able to recognize it easily. Backspace, because that's the extra space. Remember, no spaces in your variable names. You can have underscore, but no spaces. And then in the label, you can write the proper name. And in the label, you are allowed spaces, as you know. So you could write out the words, but I'm just going to shorten it for illustration. But all right, just condoms, BADFORHEALTH, rev. The spaces are allowed, words are allowed, anything you want to do. If you like the Queen's English, that's fine. So once you've given the name and the label, hit change. And you should see something up there saying now, condoms bad for health is going to be going to arrow, bad for health. And if you put your cursor over it, you'll see it's bad for health reversed. Old and new values is the button. So we will say the original value that was 1, we are now going to code it on the right-hand side, new value 5, and add. So the 1 is going to be changed to 5. The 2 will be changed to 4 because we're reversing the order as we wrote on the sheet. The 3's remain 3.
Still have to input that.
You could do this in a number of ways. You still have to input it. You could have used 3 and then say copy old value if you want. But just for illustrating what I'm doing, it's easy to see it at the end. And then the 4 is going to now reverse code to 2. And if I find it useful to have my little paper on the side when I'm doing it, especially if it's a scale you're not familiar with. And the 5's that were originally 5's are going to go to 1's. Add. And of course, you always, anything that was system missing or user missing, you can just actually say, if any missing data can still continue as missing. There are actually no missing data on this, but anything that was missing remains missing. That's all it says. Missing is still missing, not within any special code. So you'll see the new coding. 1's are going to be given 5's, 2's, 4's, 3's, 2's, 4's, 2's, and 5's, 1's. Persons online, are you going along? Just checking in.
Yes, sir. I'm following.
Yes, sir.
Yes, sir.
Great, great. And one.
How did you get the missing into
The missing, I did system missing, meaning that nothing was entered. Or if you use a missing like 999 or 888, you click on that and go over the other side, you see system missing. If you wanted, you could have gone and the 999 goes over to 999 and all kinds of things. But it's just very easy. Now, once you do that, you hit continue. And then you hit OK. The output will tell you all the things you're done. So if you want to check it, you can see the last line. It says recode 1 equal 5, 2 equal 4, 3 equal 3. The reverse thing is there at the bottom. Better yet, we can look at our database. And you should see a variable here now, condoms health reversed at the bottom. You can leave it there or you can move it if you want. Who cares? Condoms health reversed. Now, you go over to values. The values are not there. So you have to go and put them in if you want. So the values now, under the new system, 1, what is 1 is being given to? Strongly? Strongly disagree. I'm doing this painstakingly, but in my normal mode of operation, I would just write SD. Strongly disagree. Add that. The next one is 2. 2 is now disagree. 3 is undecided. 3. Add 4 is agree. And 5 is now strongly agree. Oh, okay. 5. Sorry, 5. Sure. And once you've put that in, you're in good hands.
Wait, sir. 3 says strong.
Oh, I'm sorry. Thank you. That should be undecided. So let me change. Right.
What is it about hours that makes it have the 2 decimal points at the end of it?
Okay, it's just the coding here. Now you notice you have 1.00, 2.00. The question is asked, why do we have the 2 decimal points? You click OK here, having done it, first of all. And then you can change the decimals here. You notice the default is 2.
Okay.
Beside condoms bad for reverse. If you don't like it, just go and change it to 0. You can either type it or go down. And therefore it will disappear. The 1.0, the 0.00s will disappear. So now we are pretty much there. And if you want, for completeness sake, it doesn't matter, we know that the Likert scale is an example of what kind of variable? Ordinal. So if you want to say ordinal, you can check. Correct? You see how the statistics come easy now? You know, foundation laid, you know. Ordinal, if you want to be absolutely correct. We reverse coded bad for health. We also needed to reverse code condoms are useless. And this is the beauty of SPSS. So we're going to do the same thing again, transform. We go to recode into different variables. All right. You could reset if you wish, or just take that out, having done it already. Condoms are useless is the other one that needs to reverse. And I'm going to change it to CDM useless reversed. You could give it any name that you like. Useless REV. No spaces. And then give it your proper name label. Condoms useless space reversed. Doesn't matter, you don't have to capitalize, you can do anything you want. And you hit change. So we're going to change condom useless to condom useless reversed. We go to old and new values. And this is the beauty of it. You already did this. So you should see old and new values, the same coding system already there in the box. So you don't have to go back and start and go one, one go to five go to five, and so on. It's already there. So if it's already there, you don't have to do it. But if you like lots of work, you can go and do it 1 to 5 and do it again.
Doesn't it just came up automatically?
Yes, once you click. Because you haven't come out of the system yet, so you can do it. It will be there, and if you see what is there and you like it and say that, just hit continue. So you don't have to go all over again. And then you go okay. And it will give you, the output will tell you, I've just reverse coded. If you look at your database now, you will see a variable, condoms useless reversed at the end. And again, you'll notice there's no coding. Under the values, it says none. None given. But we know, rather than go back and click the coding in, guess what? It's the same as the coding above, right? So you could just do copy and paste. So what you do, put your cursor not on the blue button, but in the just before the blue button in the white space, and you can right click, or is left click or right click for you. Right click usually it is, and copy will come up, and you go into the next space, and then just paste. And it will be there, and if you hit the decimals, you can adjust. Actually, if I knew, because I knew that the scaling would be the same, I could have actually done both of them with one swoop at the first one. So everybody is good online. Have you reverse coded?
Yes, sir.
Great. Now comes the easy part. Life is beautiful. So we are now just going to follow the instructions on the sheet. We are going to generate Cronbach's alpha, and Cronbach's alpha is about reliability. So we go to analyze. You can do it from the variable view or from the data view, doesn't matter. Analyze. You go down and you scroll down, you should see, how much from the bottom is it again? Where is it? Scale. About 2/3 the way down, you see scale. Because these questionnaires are some kind of scale, summated scale. And when you come to scale, you'll see reliability analysis. That's what we want to do. Once you click reliability analysis, a wonderful window will come up with the variables. I've expanded my window. So you are now going to bring across the items that compose the scale. So the first item was condoms are free to use. Send across. The second item is condoms bad for health. But is that what we want to use? No, we want to use condoms bad for health reversed. The third item was condoms save lives. So we do that and send across. By the way, I didn't change my variable to ordinal. I can do that afterwards. Then after useless comes condoms great for sex. Yes. Useless reversed. Free to use. Save lives. Sorry, useless reversed is the next one. The fourth one. Useless reversed. Great for sex, and then would recommend, would constitute our items. You see on my scale, because I didn't write in nominal, I didn't write in ordinal, it's nominal, but won't affect the price of rice. Now check that what you have on the items are condoms free to use, condoms bad for health reversed, condoms save lives, condoms useless reversed, condoms great for sex, and condoms would recommend to friends. Check that your mother is alpha. So you go down to here on the lower left, you see alpha is there. And that's fine because we are going to generate Cronbach's alpha. Now, if you click on the little arrow beside alpha, you see some other things. Split half, Gottman, parallel, and direct parallel. These are other ways of assessing reliability. But we are not going to be using any of those other ones right now. Give your scale a nice name. So that's where I came up with the ATCOS scale. And just for time, I'm just going to type in ATCOS. But originally on my original notes, I wrote the condom for the attitude to condom use, bracket ATCOS scale. And it sounds like, you know, we really know what I'm talking about. That's how you fool people and get paid for it. All right. Now, once you've given your scale a name, ATCOS is. Go up to statistics in your upper right. And it says, what do we want to tick off? You can get a description of the items, descriptive statistics for the items, descriptive statistics for the scale. We'll have scale if you got rid of that item. And we'll show you why that's important. Tick off inter-item correlations. These are the covariances. You remember that we said other ways of assessing reliability include inter-item correlation? You can get this in SPSS. Summaries, means, and correlations. I think that's what we said. We'll tick off in the notes, means and correlations. And incidentally, on the right, you see a box called ANOVA. So you could actually use ANOVA to test if the means on each items are different. All kinds of things. But we won't necessarily need that right now. Click continue once you've ticked off these things. And I believe we can now go to OK. Ta-da-na-na, ta-da-na-na-na. The output arrives. There they are. I have copied the output, but you can look at it if you want in front of your scale into the notes. So here it is. Top gives you the title of the scale. Then you get a case processing summary. So this tells us that there were 73 people for whom there was valid data. 2 people were excluded. And so there was a total of 75 people who were given these questionnaires. 2 people were excluded. Just out of curiosity, why do you guess that 2 people were excluded? Missing data, correct. Because they are supposed to get a score on a 5-item or a 6-item scale. If somebody did not complete the questionnaire, then you can't score them and interpret it. So that's a useless questionnaire. So it has excluded that. Because it's supposed to be a summated scale across all the variables. So here comes first neighbor. Cronbach's alpha, 0.791.
I didn't know numbers. I have 0.595.
Oh, you sure use the
Did you use, I'm sure what happened is that you picked up one of them that you did not reverse.
Oh.
Like if you look at your items, so you're supposed to have, just glance at the table below and it will give us a clue. The items are condoms free to use, condoms bad for health reversed, condoms save lives, condoms useless reversed, or she just has condoms useless.
no, she has the reverse one.
All right. So did she click OK and reverse? Meaning that you actually clicked off OK. You didn't just name it.
Oh.
Yeah, just redo it. Just double check. All right. I'll go through and then we'll come back and just see exactly where for you. So this is what you should get, 0.791. So one of the things you have to ask is, what does this mean? Cronbach's alpha is a measure of reliability. You got 0.791. Well, here is the answer to the question that was asked earlier. On page 12 of your, no, 13? 14. Page 14 of your notes. Make sure it's page 14. No, page 13 of your notes. Is the key for interpreting Cronbach's alpha.
Oh.
Greater than 0.9 or 0.9 and above, excellent reliability. 0.8 right up to 0.9, but not including 0.9, good reliability. 0.7 right up to 0.8, acceptable reliability. 0.6 to less than 0.7, questionable reliability. 0.5 to less than 0.6, poor. And 0.5 under 0.5, unacceptable. So if you get a Cronbach's alpha that's under 0.5, don't even consider that instrument for use. Now, most journals, if you're going to publish your article or you scale and you use a scale in your research, they tend to publish if you have reliabilities of 0.7 or more. But some journals will go right down to 0.65. And 0.65 is questionable. But guess what some researchers do? When they get 0.65, they round it to the nearest decimal place and get 0.7. Which is...
So let's say you can do research. You normally do like the pilot study first to make sure that they...
It's one of the things you can do. So if you're doing so an instrument that has never been used or an entirely new instrument, what you can do is do a sample of 50 to 100 people. Let's say you're going to do a 600 person study or a 300. Get at least a 50 persons and to see what it looks like. So most journals will not because if you have a scale that is not reliable, then you can't have any faith in the findings. So most journals will not even publish it. Some will publish it if your intent is to tell people that this scale doesn't work in our setting and therefore avoid it. So our scale of 0.791 is acceptable. So that's good. So this suggests that this is a reliable scale so far. Now, beside this, you see a column mark, Cronbach's alpha, based on standardized items. Now, in the scale that we had all the Likert, they were all 5-item scales, right? But sometimes you have an instrument where question 1 has 5 choices, question 2 has 3, question 4 has 5, question 5 has 3, and question 1 has 2. In such a case, you will expect that variability is going to be different because you have a 3-choice item versus a 2-choice item versus a 5. So what we have to do is to ensure that we are all measuring the items on the same scale. And that scale, especially when it comes to reducing variability or comparing variability, is you remember when you were comparing height and weight and age in that exercise way in the first term, you have to convert everybody to what? In order to compare to a z-score. So a standardized score is that all these values are calculated by the computer into z-scores, and then everything is a z-score, and then you can compare across. So if you have an instrument that has varying numbers of choices by item, you may want to look at the standardized Cronbach's alpha. In this case, you notice the standardized and the plain Cronbach basically give you the same answer, because all of them are still 5 items. So they're going to basically work out to be the same. 0.00. And if you get into 5 decimal places, then it probably will be good. But normally we use this one. But if the items are variable, then we go for the standardized Cronbachs. Next thing, the item statistics. Condoms free to use. The mean score on that item was 2.95, roughly 3. So some people might have scored 1, some people might have scored 5 on the item, but on average, people are scoring around 3. That suggests that if you took things overall, people are kind of if but undecided. Some people are saying yes, some people are saying no, some are undecided. Condoms bad for health reversed. Now, when you reverse, you're saying condoms are good for health, right? Notice the score was 3.8, going towards the 4s. So people were agreeing that condoms are good for health, generally. Agreeing, not strongly. All right. That's the average. Condoms save lives, 2.75. People weren't, they weren't disagreeing, but they were kind of undecided, somewhere there. Condoms are useless, reversed, meaning that condoms are useful. 4. So most people seem to be agreeing. And then condoms great for sex, 2.67, between disagree and undecided. Condoms would recommend to friends. People were kind of if and both undecided. Now, in addition to the mean, they give you the standard deviation, just to show you how tight, are the variations. So for example, condoms save lives, 2.75 plus or minus 1, standard deviation, standard deviation of 1. So you're getting a lot of, 67% of scores would be found between 1, roughly 1.75, and 3.75, 68%. Just gives you an idea of the variation around the mean. Apart from that, this table is not really critical. Just tells you what the typical scores were probably like. Moving on. The inter-item correlation matrix. Remember one of the things we said we could look at how each item is correlated with the next? Here it is. Of course, the items are going to be correlated with themselves, the ones. So we don't really pay attention, item to its item. So you can either read the upper diagonal of the sandwich or the lower diagonal of the sandwich. Condoms free to use. How is it correlated with bad for health, with condoms good for health? Correlation, 0.25. Condoms free to use and condoms save lives, 0.64, 0.46 rather. 0.26, the other one, 0.1, 0.1. So we are seeing that condoms, if you remember your interpretation of Pearson's correlation, these would be kind of weak correlations. Condom free to use appears to be weakly correlated, except for probably save lives with the other items. Let's look at condoms good for health, so-called bad for health reversed. We see that people who think condoms are good for health also seem reasonably to be saying condoms save lives. 0.5, a kind of moderate, middle of the road correlation. Certainly people who say condoms are good for health, bad for health reserved, are certainly saying condoms are not useless. They are useful. Condoms bad for health, great for sex, minimal correlations, and so forth. And you could go right through. You could see, for example, here, that condoms save lives and condoms are useless. Reverse, meaning condoms are useful. That, I think, has the second highest correlation. And then we see here another interesting correlation. Condoms great for sex and condoms would recommend to friends. Correlations of 0.6. So people who said that condoms are great for sex seem to be leaning towards recommending it to friends. So you could go through and just look at the correlations. You'll see in the end that we have even more masterful ways of doing it. So you could have actually come now and take all of these and take the average inter-item correlation. Take off all of these and average them. All the ones either above the diagonal or below the diagonal and average them, and you'll get average inter-item correlation. But we won't necessarily need that because we have a better measure called Cronbach's alpha. The next table is the summary item statistics. This just basically summarizes the table above. It tells you the item means the two tables preceding. The item means vary from 2.6 to 4.05. And range, of course, is the difference between the maximum and the minimum. And for the inter-item correlations, it ranges from the lowest correlation, 0.167, to the highest correlation, 0.063. It's just there to give you an idea of what the correlations are like. This table is particularly useful if you have a lot of items in your scale, because none of us would want to be going through like which one is the lowest, and searching and so on. So it just gives you that. And it tells you that the item means were about 3.2. So if you took all these items here, 2.9, 3.9, 2.7, 2.6, 2.9, 4, if you average all the means, you'd get about 3.2. And the same thing, if you average all the correlations, you'd get about 3.85. The average inter-item correlation. 0.385. All right. And the SPSS gives you all kinds of information that you don't need. It's, variance. How does the minimum compare to the maximum and all kinds of things. Now we get to the table that is, apart from the Cronbach's alpha, this is the table that is the most important.
Excuse me, sir.
The item.
I have a question.
Go ahead.
For the 0.167, which is
Yes.
condoms great for sex. Oh, feedback.
And condoms free
great
to
for
use.
sex and condoms free to use. Yes. Does that mean those who say condoms are great for sex are least likely to say that condoms should be free to use?
It means there is not a lot of correlation between those two answers.
Okay. All right.
People, there's people who say condoms free to use are not necessarily saying they are great for sex. And people who say condoms great for sex are not necessarily saying they should be free to use. Maybe they think they are great for sex, but they think that they shouldn't be free and everybody have access to them and, all can use.
Or I guess just in this context, it's hard for you to make a determination as to what those two persons or what those persons who hold those two opinions.
Who those two opinions are. I know we don't know the reason behind their choice, but it's not going well together. It's not highly correlated.
Okay.
So we go to this table called the item to total statistics. Remember we said one of the ways you can look at is the item compared to the total score. So scores could go probably up to 30 if you got 5s on all 6. And you could have a low of 5 where you get 1s on all 6. Low of 6 where you get 1s on all 6 questions. So we look at the item total statistics. We will leave the first 2 columns and go to the item, corrected item to total correlation. This means the item in its relationship to the other items in the scale collectively. So condoms free to use, how does that fit with the rest of items taken together? We see it's 0.378. Condoms bad for health, meaning condoms are good for health. How does it fit with the rest of the items? Corrected means not including that one. We see that it's moderately correlated, 0.59, 0.6. Condoms save lives. This seems to be fairly decently correlated with the rest of the items, as is condoms useless reversed. Condoms great for sex, lower end of moderate, probably. And condoms would recommend to friends, certainly in the mid-range, 0.5. So, what's the implication? If the correlation is moderate to high, that is 0.4 and above, it means that that item fits well with the other items in the scale.
This is where if you did the pilot study, you could remove some of the items.
Exactly. We're going to come and talk about that. Absolutely. So, in this situation, we are discovering that condoms free to use item question doesn't really fit well with the rest of the items. And maybe, as somebody in the class is saying here, maybe we should get rid of it because the other items tend to be fitting well, are consistent with each other. So once it's 0.4 and above, it means that the items may make valuable contributions in the scale. They fit and work together. So now, immediately, we have a little question sign against this person. Mr. Condom free to use. Question sign. Less than 0.4. That item might not be measuring the same thing as the rest. You can skip the multiple correlation, squared multiple correlation. In short, you remember sometimes you see this correlation, this square correlation, R squared, which kind of tells us, R squared tells us the amount of the outcome that is explained by that variable or contributes. So that's kind of what that reflects. So you notice that the outcome, which is your Cronbach's alpha, that condom reliability, free to use, is not contributing so heavily. It is the least. Or maybe bringing it down. So we look to the next line, which is really the key line. What would happen if you got rid of that item? Would the reliability increase? We see, if we got rid of the condoms free to use, remember our original Cronbach's was 0.791. If we got rid of it, Cronbach's would get better, reliability would increase. So we should probably get rid of it. We have a clue that it didn't work well. And now we are seeing that if we got rid of it, Cronbach's would increase. It would be better. What if we got rid of condoms bad for health? Question reversed. It drops the alpha. So we are saying keep it. Because if you throw it away, it gets less reliable. What about condoms save lives? Keep, because if you throw it away, it gets less reliable. And the same is true for all the rest. Keep, keep, keep. Consider throwing away. Come on. Oh, that's not the red. Consider discarding. We see this is a problem. And we see that things get better if we discard it. It might not be measuring what the others are really measuring, is your attitude to condom use. Might not be capturing it. The last statistic is the mean score on the scale. Remember the scale, you could score, ones and fives. If you scored perfect fives, you'd get 30. If you scored ones only, you'd get 6, right? On average, people are scoring 19.2 on the road from 6 to 30. So they were about middle of the scale, which we saw in the items, a lot of them were in the middle. So it gives you the average score that people obtained on this questionnaire. The average summated scores. Some would have got 27, some got 30, some would have gotten 6, some would have gotten 8. And that's what that tells you, basically. And the variability around it, plus or minus 3.82 standard deviation. Variance 14. So there's a lot of variation around this. So that is the interpretation of Cronbach's alpha. Now, yes, I'll do it in the next exercise. So it's pretty easy to go through. We spent a lot of time because it was the first one, but now we get it. Let's do this one quickly. There's another scale that was under investigation called the Public Health Knowledge Scale. This was people trying to assess your public health knowledge by giving you 4 questions. You know, for example, now there are shortened versions of all kinds of questionnaire. Mini mental as a short one, where they will just give you 4 questions to try to establish your mental status stuff. And the PHQ brief, you know, and so on. They're doing all kinds of money. So instead of 8 or 10 or 20 questions, they give you a shortened version.
The G6 or Glasgow Coma.
The Glasgow Coma scale is definitely one that tries to assess your conscious level. So here is the public health questionnaire. NCDs are the leading cause of death in the Caribbean. And on the questionnaire, they were coded as, 1 and 0. The best one got the highest mark. So on the questionnaire, there are 1 and 0. So this was 1 and 0, 1 and 0. Or yeses were coded as 1 and no's as 0. So let's look at if there's anything that needs to be reverse coded. NCDs are the leading cause in the Caribbean of death in the Caribbean. Yes is a good answer. So that gets the highest mark. So that's okay. Cholera is caused by a virus. That sounds like something I should put on the multiple choice in the exam. Because as is people trying to say, is it or is it not? But what's the correct answer? No. So no is the best answer and therefore should get the highest mark if we are giving your knowledge. So this should be a 1 and that 0. So this one needs to be reverse coded. PHC means primary health care. Correct? That's okay. And the last one, to test your knowledge of public health, all health care is free. We know that the correct answer is no, but right now the coding is it. And so this one should be 0 if you said yes, and 1 if you said no. So this needs to be reverse coded. All right, we're just going to push for about 15 minutes because it's our last class to be reverse coded. So let's go to our database. And remember, we are reverse coding cholera and all healthcare is free. So let's go. So here's your database with them. NCDs leading cause of death. 0 equals no, 1 equals yes. Cholera is caused by a virus. 0 equals no. So this is wrongly coded in terms of highest score. PHC, yes, gets a 1. And the last one, all healthcare free, 0 is given to no, but 1 should be given to no. So let's do transform. Recode into different variables. Let's reset the button. So everything is clean. We're doing a different exercise. So reset. Everything should be clear. And we are going to bring across the variables that need to be recoded first. The variables will be cholera is caused by a virus. And the other so we'll do that, change it to cholera virus reversed. So I'm just going to call that cholera virus reversed, REV. Get rid of the space.
Excuse me, sir. Where's this database?
It's the same one. Just look inside the same one. Just go to variable view. You see in lines 7, 8, 9, and 10.
Okay, thanks.
No, not a problem. Not a problem. So it's bringing across color reverse, label, and for short, I'm just gonna write cholera reversed. But you could write out cholera virus reversed if you wanted. Anything is okay. And you hit change on that one, which tells me that I got a space in the first one, right? Okay, hit change. All right. And you could do the same one at the same time. The other one is all healthcare reversed. I'm just going to reverse it, all health free REV. No spaces. And you can write whatever you need to do for the name, anything you want. And you hit a change on that. So when you do that, you have two variables inside that have been changed. And now you can do the old and new. And what was a 1 is going to become a 0. And we add, and anything that was a 0 with this reversal is now going to become a 1. If there was any missing data, system or user missing, we just convert it to system missing, continuous missing, who cares? And now we can hit continue. And then OK. And it should have done it. Hold on, did I select? I think it should have done it for both of them. So let me see if okay, I didn't do. On mine, it isn't there. Cholera virus and all healthcare reverse, yes. I see on my output that both have been reversed. You look at the box, you see that cholera virus, all healthcare has been reversed, all healthcare free reversed. And if you go to your database and you want to put in the coding now, you can put in, you should have two variables, cholera virus reversed and all healthcare free reversed at the bottom. You can put in your coding to say It's what now? What was it now? For these, the yeses were zeros, right? So the zeros, you got 0 if you said yes on this. No, man. Cholera reversed. If you said cholera virus, oh, yes, reversed. 0 equals. No. Hold on.
0 equals yes.
0 equals yes. That means you get no points. And 1 is if you said no, or 1 equals no. And you can actually make a quick check because it should be the reverse of what was above.
Excuse me.
And you can copy this and you copy and paste here.
Sir, I have a question.
And you can, one sec, and you can reduce the decimals so that you notice compared to the previous one, things are reversed. Zeros were no's, now zeros are yes. Go ahead with the question.
All right. So since we had done that for the feedback is getting big. All right. So condoms bad for health in reverse. We still have 1 being strongly disagree and 2 disagree and so on. That's what we had done for the previous example. So is it that was wrong?
No, this is correct because I know it, the ones, oh, that should have been.
It should have been 1 is strongly agree.
Oh, for the coding.
Yeah.
Oh, right. So 1 is strongly disagree. Right, that should have been the other way. My typing. The word disagree should have been agree.
Okay.
Thank you. That's correct. My typing. It doesn't change the values, but the typing.
All right. Thank you so much.
Yes. So it should have been the other way. All right. Thank you. Just the typing, but the values don't change. So that's why the correlations still work out on the answers. So when you get the chance, just go back and just change the disagree or disagree down here to agree. All right. So now we can run the reliability analysis. Analyze, scale, reliability analysis. Oh, let's reset this. Just reset for ease. And then we start the items that go into the scale. NCD, main cause, cholera virus reversed. All, where is the other one? PHC, primary health care goes in. And then all healthcare reversed goes in. And of course, you could have changed it to ordinal and so on and so forth. I didn't bother to fix up my scale, but if you're in a perfect world, you want it to be exact. You could treat it as an ordinal, meaning, yes, correct answers are better than wrong answers. Or you can continue as nominal, doesn't matter. Alpha is selected.
One
You give the
second,
name
sir.
as
Yes or no is not like a binary or dichotomous.
Right. So you can use anyone. You can keep it as binary, nominal, straight variable, or you can use it as an ordinal variable in that correct answers are better than wrong answers. That's why we gave wrong answers get 0, correct answers get 1. So you can choose whichever one you want. All right, so we just put in here public health scale, PUBH for short, PUBHKNOW scale. Give it anything that you want, SCALE, public health knowledge scale. Make sure you tick off the usual suspects on the statistics, items, scale, scale if item deleted, correlations, and then means and correlations, summaries. So item, scale, scale if item deleted. Then to the right of that, tick off correlations, tick off means, tick off correlations on the summaries. Hit continue, and we're good to go, and you'll get your output. And it's all here, and I've copied it and put in the notes for ease of teaching. And this one is so wonderful and easy to follow because you see it. Again, we have 73 people answered the questions. 2 people had missing data. Reliability statistics. Cronbach's alpha, 0.687. Question ever, right? All right. On the scale is what? Question ever? Or? Yes, I think it's 0.7 is acceptable. So this is going to be something question ever. Number of items were 4. I'm using the Cronbach's alpha because everything was still 2. But you notice the standardized alpha is a little bit different because of the variation between yes and no. But this one, we'll work with that. So it's a question-ever scale in terms of reliability. How do the items correlate to each other? Or the means? 0.71. What does that mean? Remember, the items really vary between 0 and 1, right? So the mean of 0.71 in this item that's only 2 means that it is somewhere here on the scale. Actually, it means that 71% of people said yes. Or said. But that's the mean score. You could either get 1 or 0. Some people got 0 and some people got 1, and so you get 0.71. And the same way, people seem to be quite knowledgeable on the PHC question, and people seem to be quite knowledgeable on the all healthcare is free question. Almost 1. Everybody almost got it right. 0.95. So, inter-item correlations. We have our diagonal. Just choose whichever one you want to read, the lower or the upper. Correlation, NCDs and color reversed, not so bad. NCD and primary health care, a bit low, the correlation. All healthcare free, a little bit on the lower side. A little bit on the lower side, but we see that coronavirus and all healthcare fee seem to be reasonably well correlated. Persons who knew the answer to whatever answer you gave to the coronavirus, if you got it wrong, you also got the healthcare fee question wrong. If you got it right, you seem to have a tendency to get the other question right too. And then these are there. Go ahead with the question again.
What's the standard we're using to know that this value is low or
is lowest? You remember your peers, these are similar to your Pearson correlation coefficient. So the interpretation is very much the same. You remember Pearson's, it says 0.67 moderate to something, 0.9 high, 0.2 weak or very weak or something like that. That's what we use, the same scale, because these are correlation coefficients similar to your Pearson or your Spearman. But if you think about it on a scale of 0, correlation means 0 and 1. High correlations to the up towards the 1, 0.9s, 0.8s, 0.7s. Of course, low if it's clearly low if it's 0.2 and 0.1. And then you have some middle of the range stuff that you might equivocate about. The scale, item means on average, people, the items, the mean of all these 0.88, 0.9, 0.95 and so on was about 0.86, I think. And the item correlations range from a low of, average was 0.39, but a low of 0.204, which is the weakest in the table, to a high of 0.62, 642. Now to the table that really matters, tells the story. Corrected item correlation. Greater than 0.4, good, keep, likely. Greater than 0.4, greater than 0.4. We have one that is less than 0.4 on this table, and this one raises a question. It doesn't seem to be well correlated with the others. This question about primary health care and your public health knowledge. Maybe you can have good public health knowledge and still don't know what primary health care, PHC, means. So it's not a good measure of convenient knowledge. Go a little further to the far column. Our Cronbach was 0.687, right? Originally. If you deleted that NCD, look what would happen. It would go down. Therefore, keep. Cholera virus. If you took out that question, it would go down. Keep. If you took out the primary health care question, what happens to your reliability? It heads upward. It's a good thing. So consider discarding on the next round at least. All healthcare is free. If you took that out, then you'd get a lower Cronbach's, which is not what you want. So these are okay to keep. These are okay to keep. This one, the suggestion is that we should remove it. All right, the scale statistics, there were 4 questions that you could score between 0 and 4. Average score of people on this questionnaire, 3.44 out of 4. So, will you or should you remove PHC? The suggestion is that you should. But there is one other consideration. One of the problems is that if you remove it, you'll be testing person's knowledge using 3 questions only. And one of the issues that may arise is, can you assess public health knowledge using 3 questions only? It's a matter that arises. And so the people recommend that if you are using a summated scale, that you should have about 6 items, 5 to 6 items. Because too few items, even though they are reliable, they might not be the best measure of your knowledge. This is why everybody says you shouldn't sit one exam to decide your final grade for the subject. People are saying that on the one exam, or aspects of the exam, Because remember, in biostats 2, in the oral examiner, you're going to have your part, which tells us about your preparation knowledge. And then you have my part, which tests your intuition and your other part of your knowledge.
That's still two. That's still
Right? So they're saying that nowadays people are saying you must get, you give them a quiz and then a homework and a this and a that. So yes, you might, for biostats 2, that might be the case, but in the scheme of your MPH or Master of Public Health Knowledge, this is one course out of 15, which is going to determine your GPA. So in the scheme of things, not so bad. All right. So when we do that, we will see that we should consider removing PHC. And in fact, what people do sometimes is they say, we will replace the question with something else and try it out rather than have too few questions. Two other things, and then we will finish here. Suppose you calculate and your Cronbach's alpha turns up negative. It means that they are opposites. The more, like the questions, one is going in one direction and the other is going in another direction. Things are systematically disagreed. The most common cause, and this is before you do anything else, check your reverse coding. Either you didn't do it or you didn't do it properly. That's the first one. It is the most common cause of a negative Cronbach. Now, if you go home where we did condoms bad reverse and condoms useless reverse, just run it with condoms bad for health and condoms useless without the reversal and see what you'll end up with. Very likely you'll end up with a negative Cronbach's. The second one, sample size too small. So you only did your questionnaire on 10 people. And what happens is that creates uncertainty and scores could flip-flop all over the place. And the third one for a negative quotient, the items are truly, not because of any coding error, systematically in disagreement. They don't fit. Poor fit all around. They could be measuring different things. So some of the items that we think is measuring your attitude to condom use may not actually be measuring it, doing something else. So if you give that negative, but this one, nearly 99% of the time, if you get a negative Cronbach's, this is it. Suppose you get your Cronbach's 0.95 and above. This would mean extremely high reliability. Pass, excellent, no, almost perfect. If that happens, it means that the items are very well correlated and in fact are almost mirroring each other. So the items on your questionnaire or your scale may be redundant. You're asking the same thing in different ways. And the items are essentially a repeat of the other. All right. Do some thinking. Suggest redundancy. of some items. Consider removal of redundant items. So you may be looking at some items in the inter-item correlation, and you see 0.99. This would suggest that the items are essentially getting the same score. And therefore, all you do is choose one item.
But sir, for us to do this analysis, wouldn't we have done the piece of the questionnaire already?
All right, two questions. I'm going to come to that. There's a very good question. Consider removal of redundant items. And then, however, caution. However, that you don't remove so many items that your composite scale has too few items. So if you have 6 items and then you realize that all 6 are asking the same question, by the time you move it, you're going to end up with 1 or none. What that suggests is that you need to go back to the ground and remodify your scale and ask different sets of questions. So you shouldn't have a question that says, let's say, did you pass the exam? And then you have another question that says, did you get 50% or more? Both answers are going to give you the same thing. It's a redundant question. So remove that.
Your has too few.
Be careful that you don't remove so many items that your composite scale has too few items. Because then you say, I'm assessing you using 1 or only 2 questions. There are some instances where people have narrowed down their questionnaire to 3 items. And what they do is they test it against a gold standard and find out the correlation between that and the gold standard. And they find that, hey, it works. So like the mini-mental question, which mini-mental status exam, which has 30 questions, they have reduced it to 3 key questions that serve as a really good screening tool. So if you're in a busy clinic and you don't have time to go through the whole thing, ask these 3 questions. And then you might get a good idea, not perfect, of who is impaired. The question somebody asked was, this assumes that you have probably tested the questionnaire so that you can know. In an ideal world, you should be pilot testing and doing all this, some of this analysis, especially if it's a new questionnaire, or if it's an already established questionnaire but has been used or validated in your environment, you should run a little mini-thing. Sometimes we don't do that. What happens is that it's the risk. You could run the risk that you use a questionnaire that's not valid, which is a costly exercise. But sometimes your experiment becomes the research that identifies the weaknesses of this instrument and suggests that you modify it. For example, the mini-mental status exam question 1. The original questionnaire has now been modified and it is now called version 2. Because over the time, they found that some questions in different environments were a little problematic. And so they modified it based on the research that has been done using that instrument, which originally seemed to be reasonably reliable, reasonably valid. So yes, in an ideal world, when we had all the time in the world, we should actually do this. Sometimes what happens though is that you look at that's why you have to do the literature review. You see that that questionnaire has been used in settings similar to your own. Or sometimes literature reports that this questionnaire has been validated in a wide variety of settings. Doesn't mean it's gonna work, but it's a reasonable thing for you to take the approach of saying, it has been used in many developing countries, different environments. I'm gonna assume this is valuable. This is valid and reliable. When you do your research, you report on the reliability of that questionnaire so that you add to the body of literature. And if it turns out that it's not reliable, that's one of the major findings of your research. But if you have the time and you have the money, a quick pilot test does no harm. Hope I answered your question. Who was it that asked?
Yes, sir, it's me. I was just thinking, for our research itself, like when we come up with our questionnaire and our question.
Well, if it is a summated scale, not a bad thing. You can say, based on the thing that we had, and you are trying to measure particular concepts, constructs, this is what we find. Now, sometimes you will find that your questionnaire, you don't have a single real summated score because your questionnaire might be covering different domains. One might be looking at knowledge, one might be looking at attitudes, one might be looking at practices, for example. You shouldn't just get an overall score for your questionnaire, the knowledge score plus the attitude score plus the practice score, and come up with an overall score. That doesn't quite make sense. You should do the attitude section by itself, the reliability of that, the knowledge section, the practice section. So you can add that as brought up. Sometimes it's not your intent to look at the reliability of a scale. Sometimes in your research, you're just looking at the actual answer that people give, and that's what's important to you, not necessarily the scale and the construct. So you may just want to know what percentage of people are knowledgeable about, the condom or as a method of flying and planning. And you ask various things about planning. Are you knowledgeable about, I'm just making up this one crudely, about condom, about OCP, about injection, about, subdermal inserts. And you could come up with an overall knowledge score for that. Because people will say, oh, yes, those will be very aware, at least, aware people. But that might not be your focus. You might just want to report plainly, 50% of people are aware of condom as a method. 20% are aware of OCP as a method. If you want to take it further and compute a knowledge score, good for you, but not critical. All right, thank you very much. If there are no further questions, please remember to write back the code on your, where I wrote strongly disagree. I should have written strongly agree. So just correct that just for your sake, please.
Dr. James?
Yes.
Okay, good afternoon. So just one question. So we do a Cronbach's and we realize that a question doesn't fit. We're reporting it in our manuscripts. Where does it go? How do we navigate that?
All right, couple of things. One is that you can actually set up, you remember one of the things that you can't publish everything in a paper.
Mm-hmm.
You might have a paper reporting on, questions and knowledge and what have you. And you might have another paper looking at the reliability itself of the instrument. That itself is a paper, properties of the instrument. And so in those cases, you talk about it and, raise all the issues. You might even want to look at which questions seem to be the problematic ones And though you might not have the perfect solution, you might even, in your discussion, assert. For example, one of the things that was found, I remember Prof. Shearer was doing a questionnaire about in mini-mental, and there was a question about, this was years ago, many years ago. They were asking some very old people about, what is what? Was it independent, or was the first prime minister, or something like current prime minister, something like that. Current prime minister. And among the oldest people who were 90, they couldn't answer that. But they could tell you when was the Queen's birthday. Because they had grown up all their lives celebrating the Queen's birthday. But if you ask them when was Labor Day, it didn't make a sense. Because Labor Day, current Labor Day, I think it used to be Empire Day or something like that in the British system. So sometimes what you have to do is when you pre-test it, you may modify a question, but you have to make sure that it's capturing the essence of what the original question, and you report it in your interview to say, this question in our setting was modified to read ABC. So if you're on a question to look at meat intake and you're going into a place that is Muslim, I don't think you should necessarily have pork as the main choice. You might have to say what other protein do you eat, and something along that line to capture the essence. And that's the purpose of pre-testing and pilot testing. Yeah, and the current head of state might not be the right question to ask. There are better questions to ask. So yes, you modify as you go on, and everything is a learning process. That's why questionnaires keep being modified, keep changing as the research produces the direction in which we should go.
Okay, so thank you.
All right.
For the last
And
thing,
remember, not everything is bad. Not everything that is bad is useless. Sometimes if you find something that is untoward, it may be the beginning of great things.
last question, which one of the presents we should change the code with the premium one or
I think it's color reverse and color reverse and condoms bad for health reverse. And my thing, I wrote one equals strongly disagree. When I should have written one equals strongly agree.
okay.
Right. So, I mean, the coding itself is properly done. It's a labeling. That just needs to be done.
That's where it is in the early. If it is a game one,
Oh, yes. Your code book, yeah. Pretty much that's basically it. And I guess Mrs. Chin, maybe we'll talk to you more closer to the time about the exam. It's the easiest exam in life. You cannot fail it unless you want to. Because the topic that you are preparing is 50% of the exam. So if you can't prepare your 50%, God give you some. No man, it's easy. It's easy. It's very hard to fail. But if you know your stuff, you'll do very, very well.
focus.
Oh. Stop share. I now must try to navigate Because everybody is trying to now go by Barbican because of Leonie.
Of course.
And Barbican is now becoming as congested.
So what is the cause of all this traffic?
The whole
Wellington.
Monroe Road, Wellington Drive, everything down some is a mess.
Question, sir.
Yes,
Asking on behalf of Janelle, you had helped write a paper. I think it was the management of asthma in, I think, the pediatric population in Kingston, St. Andrew or so. That one, I think it is your third author with rickets rooms and
with the Gina criteria. And,
right, but the paper is currently paywalled.
Okay.
So asking if it
Tana upstairs has it.
Okay, so she's there now.
She wasn't in earlier, and she might not be in today. But you just send her an email.
Okay, so
Tana, because she might have she should have the electronic copy. I don't think I have it. Tana dot.
I also have her number.
Is that okay?
Jen,
Go ahead.
could I ask you to ask if you're still online? Oh. No, I'm saying I'll ask. Free the group chat.
Okay.
Rooms, not I don't have under.
Okay. Don't worry about it.
Yes. 99. And the email is Tana, TANE dot Ricketts, RICKETTS, rooms, ROOMES, ROOMES, at UWI.edu. No, at UWI.edu. Somewhere that way.
Thank you, sir.
You know, WhatsApp our son and then our corner and just say, you know how these people are interested in finding it. That's the one with the control and the criteria and how well we are not doing with our asthma control, right?
Yeah, that one. General says thanks.
Yeah, but how well we are not doing. Which is the same thing with cholesterol, hypertension, diabetes. It's just awful. And you can do better. For example, when you're in the practice, every time when the diabetic comes, I spend nearly 1.5 to 2 hours. Sometimes we bring that you have to use it. You never get control until you really sit down and explain and continue. And then you add to them, you give them materials. It never works.
It's just a production line.
Just this how you're feeling. The sugar, all right, yes. Let's say it's a nice, not so bad sugar.
Yeah, like
fasting is at 7, 8, and not 19. We don't really spend the time to sit down and say, how we are really going to treat this person. Let's take a proper dietary history, a proper thing, and see if we can make a difference and move it from 7 to 5.
I think a proper introductory course, especially for maybe hold on to say, like SHOs, when it is that they just come on board.
Listen,
because
they just go like that, and just rewrite the medicine and just say, Miss, you're going like fasting 8, back in 3 months.
Yeah, as a former SHO, that is exactly how it is. Yeah.
And when you have 100 and 200 people line up outside, I mean, sometimes you have all intentions, you'd like to, but you can't in the reality of it.
And you can't bounce every patient to say have against MOIC because again,
Exactly.
But not going to make clinic very fast.
And so we just having the chain. And so in all of them, 10 years time.
Only time it is a prescription changes when we get the referral letter from hospital to say, this is a new
That's a
prescription.
new prescription. And then 10 years, 15 years time, all of them come back stage 5 kidney disease. Because we've been watching them for decline for 20 years. And we never, it's really, really pathetic.
It is.
And I find that the patients, if they really see you're interested and they learn and to say, I can do something about this. Every time I see this lady, the patient them come in and tell us, say, Doctor, I'm not eating much, pure fruits and vegetables. What are you eating? Watermelon. Because them think say watermelon full of water. And and even the sugar spike. And then tell us say, Doctor, me not eat no salt, me cut out the flour, me cut out this. I just watermelon alone I eat. I'm saying you can't understand, but this is what they do.
Yeah, it's just.
I mean, they sit down and tell you, they eat pumpkin. And they're not taking a small slice, they're taking a big size of pumpkin because pumpkins are vegetable and vegetable is good. And we just don't, and we just keep them beside. And we got someone that has not the idea. Most of them, and I guess that's human nature, because we have a culture against human nature. That once they start, enjoy prevent and enjoy everything.
Mm-hmm.
And
It's just
say, he's just rescue, right? Like the idea is, but we don't feel bad.
Yeah. Nobody's having an asthma attack until they're having an asthma
Until they
attack.
have that next one now. And we're just not doing a good job as we should in terms of our clinical practice. And it's a common disease, isn't it? Respect of common disease. We do the poorest job at living management.
Because, I don't know. I think I always think about, I can't remember like the validity of the study, but in terms of that they find that physicians are less likely to start up on, I want to say, the anti-cholesterol medication if it's like the afternoon as opposed to
Interesting.
yeah, like it's like you always kind of
No,
pressure during the
interesting.
day, but then like as it is as the day progresses and in the afternoon it's like the physician just kind of
They're not dead.
can't come back.
Very interesting. I never thought about that,
Time of day impacting basically which medications you end up like if it is like going to start up somebody on a new medication
Yes.
because I guess part of it is just kind of like your brain tired at that point in time.
And you can't bother, can you explain everything. So the next thing you just say, from the next clinic, and then the next clinic becomes the next clinic, and becomes the next. I really think we can do better. I really think we can do better. But it is life for what it is.